How are you guys doing today? It's so nice to see you again after a long time.
We do apologize for shortening you.
It's okay. So there is a change of plan. Instead of giving you your next exam on November 1st, it will be October 29. October 29th, Tuesday. But I'm not gonna, after next week. But I'm not gonna give the exam on E-Tech chapter 11. I will cut into some section, probably 11.4 or something, and then you have exam up to that point. Okay, or maybe I can do 5 and 6 and skip 4, and then the 4 will be in the next one. I'll see what to do after next week. Okay?
We get it back on the 11th.
No, I'm saying instead of having the exam on November 1st, I'm moving it one day before until October 29, because on that day, there are so many students that have the registration appointment. So it's not given the next week because I have to grade it over the weekend before the next week starts. The last day to drop this class is 5th or 6th, something like that. So I have to submit my grade before that by the department policy. So I definitely have to give you either 29 or fast. Fast is a bad day, so I'm going to give you on 29. And you're going to get your grade before the dropping date. And if you have to drop, you can drop. Okay? Huh? Some students are not doing so well class. So if they don't drop, there is a high possibility that they're going to fail. So if you don't want to get F or D, it's better to drop the class. It's 2 points, not 2 points. It's 2 credit class, so you're allowed to drop. You should not drop, but if you think there's no way you can pass with me, then dropping is better than having an F. Okay, so we're done it. 11.1, 11.2. We basically did nothing. We talked about how to solve quadratic equation using complete squared or quadratic formula. And in quadratic formula, whatever we have under the square root, we call it discriminant. And based on the discriminant, we can know how many solutions we are going to have, or if we have any x-intercept or not. So we talked about this in our last class, and we did one example. What comes in the final exam about discriminant? This is this type of question, and we are done with discriminant and solving quadratic equation. 11.3 talks about solving non-quadratic equation using quadratic methods. It means the problem we are going to see, they don't look like quadratic. So they are not quadratic equation. However, when we try to solve them, eventually they will turn into a quadratic. So we can either factor them or you can use quadratic formula to solve them. So example 1, it's a rational equation. It's rational because it's a fraction. Anytime we have fraction, we call it rational. Definitely doesn't look like quadratic, right? But once we bring everything to one side and then combine our numerators by having the same denominator, we will see that it comes into a quadratic equation. That means either we can factor it, it's possible. And if not, if factoring is not possible, then you can use quadratic formula or complete the square. Okay? And the final exam will have at least one of these. So there are many ways of solving this. The way I prefer and I found it's easier is always bring everything to one side and have 0 on that. So anytime they ask you to solve something, make sure you see 0 in one side so you can solve easily. So let me write down the steps real quick. First step, we are going to bring everything to one side. Bring everything to one side of the equal sign. Once we bring everything to one side, let's do it. So we don't want this. So we are moving this. We get 3 plus 4 over x squared minus 8 over x equals 0. You don't have to, but I found this is easier. Bring everything to one side, and now we need LCD because we have to combine all three things. So find LCD and combine the top. So our goal is to add everything and subtract here, add here, subtracting here, and we subtract everything together, but we cannot do that until we have same denominator on every denominator. That means it's time for LCD. So what is the LCD between x and x squared? X is a common factor. X squared. So factor and LCD, they're opposite. When you factor out something, we look for the smallest thing. But when you go for LCD, we look for the bigger thing. Why? Because LCD means least common denominator. So what is the biggest denominator you can have by which you can divide x, and also you can be able to divide by x squared evenly. X squared, right? We can divide x squared by x and we get x. We can divide x squared by x squared, we get 1. So x squared we can divide by all the denominators, so x squared is our LCD. If you think x is the LCD, look what happens. X over x is 1, fine, no problem. But what happens here? If your LCD is x, you can divide that x by x, no problem. But you cannot, so it's other way around. But you cannot divide this one. It will be one over x. But we don't want a fraction, we want something whole. So that's why LCD must be something big. So that you can divide that thingy by all the thing you have. So this is x squared. So the general rule, let me write it down. It says, let's say you have same base, but multiple powers, like x, x squared, x to the 5, x to the 10, x to the 100. You have the same base, but powers are different. So if you have same base, but different powers, LCD is the highest power with the base. For example, we have x and x squared. Obviously, x squared is bigger. So LCD must be bigger. X squared. So if you have same base but multiple powers, the highest power in the base is LCD. Well, why do we care? We care because we want, let me write this down again. 3 plus 4 over x squared minus 8 over x equals 0. We care about LCD because we want the same thing here, here, and also here. We want to have the same denominator on every denominator. That's why we figure out what's the same denominator we want to have. And we find out we want to have x squared as our same denominator. Okay. It doesn't have any denominator, but we want x squared there. We cannot randomly put x squared in the denominator, right? But it's fair. If you put it in the denominator, what do you have to do? You must put it on the top. So we multiply 3 with the x square. The second fraction already has the x square. Do we need to do anything on there? We already have what we want. Third one has x, but we want another x, so they turn into x squared. Since we want one on the denominator, what do you have to do on the top? Put an x. Same thing. And now we're happy. All of the denominators have the same. So no more discrimination. Here we discriminate. We didn't give anything to t. Here we gave one less. And here we gave everything perfect. So they are not equal. First step, we make them equal. And while we make the denominators equal, we also have to multiply the numerator by whatever we are putting extra on the denominator. Once we are happy, we write the denominator only once. Because they all are the same thing. So why wasting our energy writing it 3 times? We write only once and we combine all the numerator. 3x squared plus 4, 4 doesn't have any x, plus 4 minus 8x equals 0. So this is what second step says. Find the LCD and combine the top. So we are done with our step 3. So step 2. Now the next step we want is, we hate denominators, right? We don't like denominators, we don't like fraction. So we're going to get rid of the denominator. Get rid of the denominator. How can we get rid of the denominator? If you don't want the denominator anymore, what do you do? Multiply the top. We multiply the top by x squared on both sides. So they cancel out. You can multiply the reciprocal. So our x squared is the denominator, that means you have x on the numerator. They're reciprocal of one another. So multiply both sides with the denominator. Whatever you have, the denominator cancel out. So we left with 3x squared. And let me rewrite that. It's not in order, right? 4 is, the constant is first, and then our x term. So let's reorder them. Minus 8x plus 4. What is 0 times x squared? 0. 0. 0 times anything is 0. So we got rid of the denominator, and we have only numerators equal 0. Next, we are going to solve. And now we have many choices. If it's factorable, we are going to use factoring. If it's not factorable, we can use quadratic formula. But our goal is to solve for x. And we have choices either by factoring, if it's factorable, or if it's not factoring, using quadratic formula. What do you think? Is it factorable? It doesn't look like it's factorable, right? Yes. Because x squared has a number in the front. Guess what? When x squared has a number in the front, there is another factoring technique. The name of the technique is AC method. We don't factor directly because it's not directly factorable, but observe what happens if you multiply A with the C. 3 times 4 gives us 12, right?
You said AC method is for when x has a
X squared.
x squared has a number for them.
When x squared is alone, we can factor directly. But when x squared is not alone, we definitely cannot factor directly, but we can use AC. AC method says multiply A and C. We did that. And now do the same thing what you did before. Figure out two numbers, multiply to 12, combine 2 in middle term. Can you think of two numbers, when you multiply them, it becomes 12, and when you add them, it becomes -8.
It's -2.
It's definitely 6 and 2, right? The bigger factor must have to have the middle sign. That means it's guaranteed 6 has to be minus.
We can just do the quadratic formula if we don't want to factor, right?
But if you do factor, it's easier. It makes it simpler. Then 2 has to have what sign?
Negative.
Negative. It cannot be positive because -6 plus 2 is -4. We don't have -4, we have -8. So 2 has to be minus. Okay, we found the two numbers, multiply to 12, combine to -8. And then what do we do? Why do you care about these two factors?
Now we treat x squared minus 6x minus 3 plus 4.
We are going to rewrite this 8x with -6x and -2x. This -6x minus 2x is a -8x. So we are not going to write 8x anymore. We are going to use those two numbers. Why? Because look what happens. We have 3x squared, we don't change. We have 4, we don't change. In the first line, we had 3 terms, right? But how many terms do we have on the second line? 4 terms. And we love having 4 terms. You know why? 4 is an even number. Why do you care about even? When you have 4 people, what can you do? You can group them, right? If you have 3 people, you cannot group them evenly. But when you have 4 people, you can always group them evenly. One group get 2 persons, another group get another 2 persons, another 2 people. So when you have 4 terms, we do grouping, factoring by grouping. That's why we rewrite 3 terms into 4 terms so that we can factor by grouping. Now look at each group individually. In the first group, can you take out anything as a common factor?
Yes.
What do you see?
3x.
3x. And if you pull it out, what remains? X minus 2. Now look at in the second group. What can you pull out? 2. But 2 has a negative sign in the front. So you must pull a -2. Great. What remains? 3x minus 2. We had +4, but since we took out a -2, the +4 turns into a negative. -2 times -2 gives us a equal. How did I get what?
You get 3x.
In the first group, what do you see in both of them? Now you see 3. You have 3 here and you have 3 in 6. So when you pull out 3, 3 divided by 3 is no number, but 6 divided by 3 gives you 2. So you have a number for the number. For the variable, you have x squared and x. So they both have x in common, we pull it out. So from x squared, you took one of the x out, you left with another x. But for the 6x, you took the x out, so no more x. You have only the number 2.
You just take away the x.
Because between 3 and 6, you can also pull out a 3. You're supposed to pull out whatever you can, whatever you see in both terms. But we still have our 2 groups. So in both groups, do you see something in common? Yes. What do you see? X minus. So this time we pull out x minus 2. So what is left in the first group? 3x, and the second group is minus 2, and they all have equal 0. This is called AC method. We rewrite 3 terms into 4 terms because we want to use grouping methods. We look at groups individually, pull out something, and then at the end, we pull out another thing from both groups. Julia. You can use quadratic formula.
Here,
Hmm?
we will use the quadratic formula.
If you want, you can use quadratic formula. If you think AC method is harder for you, work with quadratic formula. About what?
How does that go with that?
So we have 3x squared and 6x. What do you see in both of them? 3. So from the number you pull out 3. Now from the variable, what do you see? X. So this is 3x, this also 3x. They're pulling out 3x. Pulling out means we're going to divide now. So 3x squared divided by 3x. What do you have? The 3 cancel out, 1 3 you have x. Now you have 6x, you're dividing by 3x. The x cancel out. And what is 6 divided by 3?
No, but how did the bottom one, how did you get that?
We do the same thing in the second group.
No.
So from here, we got this one. So this 2 was our first group. This 2 was our second group. We still have our 2. Now look at both groups. What do you see in both groups? So we do the same thing. We pull it out. So in the first group, what is left? 3x. And in the second group, we left minus 2. So 3x minus 2. Oh. No, we tried. Because it's going to waste time. We don't have enough time. But if you do want to use quadratic formula, make sure you remember the quadratic formula well. So I prefer AC method because this makes your life easier. What if quadratic formula is a bigger number under the square root? You get stuck. So now we try to solve x minus 2 equals 0 and 3x minus 2 equals 0. Then what is x? And from here, what will be x? 2/3. But we are not done, you know. Just because we got some solution, it doesn't mean we are done. It's a rational problem. For any type of rational, what we cannot have on the denominator? 0, right? 0 on the denominator makes everything invalid. So we have to see what number makes the denominator 0. If we have that in the solution, we cannot accept the solution. We have to disregard. Go ahead. Step by step. I didn't do step by step. You add 2 fast to both sides, and then you divide by 3. Check by setting LCD not equal 0 and solve for x. So we don't have to check all the denominators individually. We can simply look at our LCD and figure out what we cannot have. Our LCD is x squared. Definitely that LCD cannot be 0. Why are you taking LCD? Because LCD has all the denominators. This is what LCD means, least common denominator. All the denominators we have in the original one, LCD already has everything. So you don't have to look at every denominator individually. Just take the bigger one, and then you get all the information from there. So if x squared cannot be 0, we take the square root. So x cannot be 0. We found x equals 2 and x equals 2/3. Do we have solution x equals 0? Am I right? That means we are happy. We wasted our time by checking the LCD. But guess what? It's not to check. Because sometimes what solution we got, we also have the LCD cannot be that number.
So as long as our, like,
We found two answers, 2 and 2 types.
Yeah.
And we found that we definitely cannot have 0 as our x.
Okay.
So we are happy because none of the solution we got has 0.
oh,
But sometimes the solution we get will make the denominator 0. So we have to disregard this. Okay, you try one. One of them. I'm going to do 2, the second one. But you try one of them, no problem. And you can check your answer if you do both. I don't even see. Here we have -9.8. And here we have -1, -3.5. These are the answer for this two. Do anyone, no problem. But I'm going to do 2 in class. It's the same method. Bring everything to one side, find the LCD, multiply top and bottom by whatever you don't have to get the LCD. Once you have the LCD, cancel it and work with the new method. If you don't like AC method, use quadratic formula. But we use AC method only when x square is not alone. If you have your x square alone, factor directly. Don't waste your time with the quadratic formula. Just factor. Both of them are negative. If I'm not wrong, okay? Sometimes whatever I have the answer. It can be wrong. It can be wrong. I didn't check them. And it's a good time to say. Really? We are meeting after 15 days, 2 weeks? Really? When is the last time we met? Last week?
October 8th.
October 8th. Oh, I don't have the attendance for that day. So I missed that. So in that day, what sent? Oops. Or 10 days. 15?
For me.
He'll be here next week, right?
Yeah, absolutely. That's the last week of
Angel
October.
here, Stephanie here, Chris Nelly, right? Here, Mary Elvis, here, Chris, here, Cassandra, here, Angie here, Parker, absent, Tenzin here, Yaribel. Yaribel. Neva, absent. Julia. Gavin here. Gerald. Absent. Marsh here. Yvette. Yvette, you are here, right? Mhm. Ryan here. Christian here. Ian here. Joe here. Jannah here. Dunhill here. Cole here. Isabella here. Dua here. Nazima here. Zihong here. Matthew here. Chris with K. Absent. Cindy here. Melanie. Tony. Ah, I thought I saw you somewhere. Shri. Absent. Jocelyn. Jessica. Ready? Go ahead.
Oh, yeah. You can look the numbers when you multiply them. And when you add them, they become one. Yeah.
Did I start this? The quadratic is on the. Did I?
Yeah. Sorry.
In it out to you. Sometimes you struggle with the
But I go to burn. Yeah, yeah. Yes.
Yeah, that part.
That way.
That.
Oh.
I'm gonna say yes.
And then burn.
If this is on the test, I would take my time like small. That's it, I would, yeah. I could play it safe.
That's 5x. Yeah.
You got it? Oh, yeah. I don't know. And go over that. Yes, you just plug it in. I got. Yeah. You got it.
Yeah, wait. Hey, bless you. Oh.
I know
Okay.
it's so much. Right. Direct actually. Yeah,
You really don't see the friend. Like,
No, I'm. Right.
So definitely not this yeah, and then that's a much conception. We try to be trouble with how do you know that sort of the big number? You know how to trouble with it. Birds, right? So I know it's like, okay, so it's 89. Well,
wait,
Yeah, I'm gonna be. You guys make everything over to the left side. Let me see.
wait,
I'll try it out. So is this the
Then you gotta, one X plus one X. All over X.
What? I just saw it.
That's what.
No, let me say.
How do you check? Put it down and put it out and put it up. So for this, you, so then whatever we get, gets the best.
Wait, can I get this?
Wait.
No, wait, I did the factory math.
Yeah.
Wait, so do us finish or?
No, you have to solve. So set each of them equals 0.
The X equals -8 plus 9.
No, the other way around, -9 and +8.
So it's numbers that multiply give us the third term.
Constant.
And add constant and added give us the second.
B. Chris?
I messed up.
You actually did pull it half that way. So I know.
Of course not. I gave it as answer for you to check.
Okay, so I got the -1 part correctly, but I don't know where I messed up because you said it's negative.
Yeah. You gotta
Got
put
it.
it up.
But
I could be wrong. This is both negative, so let's see. 5 times 3, 15, so +5, -3. Yeah.
is one of these
I'm
supposed
wrong.
to? Oh,
Because here you must have to have a plus, so you have a plus. That means you have a minus here. So
no,
this one has to be
that
plus.
this is that part. So
So you have a minus here and you have to have a plus. My mistake.
okay.
Sorry.
Sorry, it's okay.
That's what I said. I could be wrong. This is actually wrong, I think.
Wait, so I got it. That's right.
Yeah.
Thank you.
Okay, I'm gonna do second one. 5 plus 2 over x minus 3 over x squared. So we have everything to one side. We don't have to do step one. We go to step two directly, look for LCD. And by now, you already know what is our LCD, right? What is our LCD for x and x squared? X squared. Good news, in the final exam, they will have x and x squared. So you'll know that denominator is x squared. Okay, so we want x squared here. We want x squared here. And third one already has an x, we don't have to do anything. So what do you multiply 5 by? What do you multiply 2? X. And do you have to multiply 3 by anything? No, because you already have the denominator. So we got lazy and we write the denominator only once. And we have 5x squared plus 2x minus 3 equals 0. So we combined our numerator, but it's time for the denominator to go out.
The left side and the right.
We're going to multiply x squared on both sides. So denominator get kicked out. 5x squared plus 2x minus 3 equals 0. And now we are happy because this is a quadratic equation. So we have two choices. Since we see our a, so we have to use AC method. Or if you don't like AC method, use quadratic formula. I'm going to do AC method because I hate quadratic formula. Why? Because quadratic formula has a downside. If you have a square root of 289, how do you know what is square root of 289 without using calculator? You have to multiply two. Yeah, what two numbers? These are the 89, 289. See, 17. But are you going to multiply 11 times 11, 12 times 12, 13 times 13, 14 times 14? Are you going to multiply 1 to 100 if you get out what gives you 289? Finalize them as 2 hours, 30 questions. You don't have enough time. So it's a bad idea. That's why AC method is much easier. 5x squared plus 2x minus 3 equals 0. If you cannot factor using AC method, then you have to use quadratic formula. So AC, it says multiply 5 with the negative 3, we get negative 15. Which two numbers, when you multiply, you get negative 15, and when you combine, you get the middle term.
5x minus 3x.
5 and 3. One of them has to be plus, one of them has to be minus, right?
Okay. Plus 5.
The bigger one must have the middle sign.
And negative 3. You said a bigger one has to have the middle sign?
Always. Middle sign. Our middle sign is positive, so our bigger factor has to have the middle sign. Whatever you have in front of x. So we rewrite this as positive 5x, negative 3x. That gives us positive 2x. And we don't change anything here. And we also don't change anything there. So you don't change the first term or the constant term, but you rewrite the middle term because our goal is to convert 3 terms into 4 terms. We want 4 terms because our goal is to group them. So what do you see coming in the first group? 5x. We pull out what remains? X plus 1. Then you go to the second group. What do you see in common? Negative 3. We pull out what remains? X plus 1. But we still have our 2 groups. What do you see in common? So we pull it out. And what remains?
5x.
5x minus 3. See, it's only 4-line solving process. Search YouTube, use AC method, and then you'll have many examples. So we set each of them equals 0, 5x minus 3. That gives us x equals what? And for the other one? Here. So this is not negative, this is positive it. But we still should check by setting LCD not equal 0. Because we want to see what we cannot have in our solution.
So we check by making the LCD not equal to.
Because that's the thing we cannot have in the solution. And we have the same thing, x squared, that cannot be 0.
Because if it will be 0, the answer will be 0. That's why.
If sometimes, maybe this was 0, okay? Suppose, let's say we solved it and we found this was 0. So are you going to accept that? We cannot, because we found that when x is 0, the denominator becomes 0 and we get something undefined. So that's what we want to see. The two solutions we got. Are you going to accept both of them or you cannot accept at least one of them?
So when you say that the LCD can't equal 0, you mean the first LCD that we found?
We have only one LCD.
One. Okay. Okay.
Same LCD, right?
So
LCD
one-
always
Yeah.
one.
The one with the like first line. in the equation.
Explain.
So we take that LCD because that LCD has all the denominators. The two choices. I just simply take the LCD and solve it x from there, or take all the denominators individually one by one and solve for us from each one of them. This will take more time, right? If you take all the denominators and see what we cannot have with denominators.
So if one of the answers like does 0, then
We cannot take it.
do we only submit one or?
No, one. So if this was 0,
Yeah.
then you're not going to take it. That would be the only solution.
Gotcha, yeah.
But we are lucky. The two solutions we got, none of them are 0.
But for that, x has to be 0.
So when we solve for x, we found that x cannot be 0.
Yeah, that's just.
The next one. Whatever makes the denominator 0, we cannot have that in the solution. Just like the radical. When you did the radical, remember after you solve radical, you always check and see is one of them gave something that doesn't work on both sides. Same thing here. Whatever solution you got, we have to check is either one of them makes the denominator 0.
So if it's 0, like that's not the answer, or?
If we have 0, that means you cannot have that as a solution.
If you need something else.
You have the other one. Whatever is not 0, you take all those numbers as well. So this is not 0, this is not 0. We are happy, we take both of them.
But it's possible for it to be 0. Right?
It's possible to have something that makes the denominator 0. So this is one example.
Wait, example.
Go ahead.
How come it switches to -1 and not +1?
We have x plus 1, 0, so we subtract 1 from both sides. So x is negative. That's too bad, it's eating late.
Oh, okay.
Is that gonna be on the exam? Good.
It's not hard.
Wait, on the final exam or the exam that you're gonna give?
In
Yeah,
the final, they give sometimes this type of
No,
question.
are you gonna give us the next exam? On the exam too?
Because this is one of the best example why we always check.
Show us like mine, the 0 things. I don't. Mine's gonna like stop.
Okay, so the two examples we did, we had only x but x squared on the denominator, right? So we didn't do anything, we simply went and got the LCD. But now we have something weird. X plus 6 and x squared minus 36. Looks weird, right? Complicated.
Yeah.
X plus 6, we have nothing to do here. It's x plus 6. But how about x squared minus 36?
They have another factor.
What are the factors?
I see x and z and 6. So 6 times 6 is 36. I don't know if it's something.
Can we factor x minus 36? Can we factor x squared minus 36?
So, yeah, because that would be 6 and then the, wait, are we factoring
Yeah, you
both sides?
multiply the first.
This is already
Yeah, 'cause-
simplified. We cannot do anything. Yeah.
Wouldn't you make that x plus 1, x squared minus?
No, the first one you have to multiply by x minus 6, and then you would get the 4 over x squared minus 36.
See, x minus.
Oh, wait.
So this is already nothing to do. It's simplified already. But this is not simplified. We can factor x squared minus 36 because it's difference of perfect squares. It's x squared minus 6 squared, right? So we can factor. So if you can factor any denominator, if step 1 should be always factor the denominators first. We didn't do that in the first 2 examples because we had nothing to factor. But now this is a new type of question where the denominator is factorable. So we get x plus 6, x minus 6. Let me rewrite. But remember, we have to bring everything to one side, right? So let me bring everything to one side.
Yeah. I was gonna ask you, does it matter where we put the 0? Like, could I bring?
You can bring left on the right or right on the left. It doesn't matter. It's easier. Which one you are moving, the left or the right?
That one to this side.
Okay. So since we have to move everything to one side anyway, let me move that in this step. So we have x plus 6, x minus 6, the first one. Then we have 4, and we moved the other one, x over x plus 6. But let me get more space. So step 1, factor the denominator if possible. So we factor the first denominator. This one is already factored. We have nothing to do here. So we don't touch that. But x squared minus 36 is factorable. So we write them to 2 factors.
So if we were to have the second term x over a factorable binomial, we would factor it?
So you look for LCD. We have this big thing on the first denominator, this small thing on the second denominator. I mean the third denominator. If you observe them, what do you think is the bigger thing that you can divide by x plus 6, x minus 6? Also, you can divide that by x plus 6. LCD means something big, then you can divide by all the denominators.
It's x plus 6, x minus 6.
We get LCD from the denominators, right? Our first denominator has 2 things, second denominator has only 1 thing. So which one we have to have in our LCD?
Couldn't we just put all the terms over the same denominator? And
What is
then-
the same
And then
denominator?
factor? It would
What
be
is the same
x
denominator?
squared minus 36.
But x squared minus 36 doesn't have x squared minus 36. This one doesn't have x squared minus 36, right?
It'd just be a-
That's why you have to factor fast. This is x squared, yes, x squared minus 36 is
I
LCD,
have to do it.
but you don't see it in there,
No,
right?
like, how to see you do it so that I can.
So that's why you have to factor fast. X
Okay.
squared minus 36 is both of them, right?
Okay.
And now you know LCD is both of them.
Oh.
Right? Not one, it's both of them. So remember, LCD means something big from the denominator. That big thingy, you can divide by this denominator, and also you can be able to divide by this denominator. So between these 2 denominators, which one is bigger?
What?
Obviously this one.
What's that?
Obviously this one, right? the left one. So this is the LCD. So what I was saying that if you take the bigger one as LCD, you can divide by both denominators. You can divide by this, you get this on the top.
Wait,
You divide this, you get one on the top.
6 times x plus 6 divided by x plus 6.
Never mind. I was telling you that how do you know what is LCD? How do you know that that thing is an LCD? So we know that thing is LCD if we can divide that thing by all the denominators. So this is divisible by this, definitely. And this is also is divisible by this, because you can cancel out x plus 6.
And then we leave x minus 6.
Brilliant.
The fraction. That was definitely.
Another denominator. So our LCD is both of them, x plus 6, x minus 6. First denominator already has the LCD. Second denominator doesn't have the LCD, so we want to have the LCD here. But we cannot just randomly put on the denominator, right? We must put the same thing on the top. The third denominator has half of the LCD. So what is another half? So multiply top and bottom by the other half. So you figure out what's the LCD. If you're confused about LCD, go search YouTube. Still like episode. Go search YouTube and find out how to find LCD. I would have explained it with more details, but we don't have time. So I have to skip that. So your job is to find out how to find LCD. Once you're comfortable with LCD, then the next is easy. We want all the denominators to have the LCD. First one already has it, no problem, we do nothing. Second one has nothing, so we multiply by both of them. But we cannot just multiply the denominator, we also must multiply the numerator. The third one has half of it, so we just need another half. So we multiply top and bottom by another half delta. And then we get lazy, we don't write it 3 times, instead we write it only once. X plus 6, x minus 6. Okay, make it short. And we combine all the numerators. First numerator is 72. Second numerator, all 3 of them. But when you multiply 3 things, first we multiply 2 things and then we multiply the other thing. Right? That's why we multiply. Right, guys? So let me keep my 4 and multiply x plus 6 and x minus 6. That's going to give us x squared minus 36. So I wrote this first. And then let me keep this one for now. First numerator 72. Then you have plus, kept it. Then you have 4 times this thingy. So I have 4 times their product. Why? Because I'm lazy. I don't want to write the same thing again. Okay? So I'm multiplying here. So in the next step, I'm just going to distribute the 4. It will be enough. And here, I didn't do anything. I kept it because we have a minus in the front.
What's that step that you mentioned that makes it 4x squared minus 36? So like, why can't we just, I didn't really understand that. So why can't we just have that thing?
No problem. Bring it here. That means you have to do one more line.
Oh, so just.
I don't want to
just
do one more
simplify.
line. Done?
No.
What do you do next?
I wanted to tell you what I meant. Because that meant. So I was asking why we couldn't just do
This is what you showed us before.
See, you're so smart, you could see that,
Yeah,
but not most students don't see that.
yeah, but that can I do that instead?
Of course,
Oh, okay.
you're smart, you
You
got
see,
it.
so do that first and then factor. That's what I was. So I can do that. Okay.
You don't have to follow math in one way. If you can see another method, no problem, go for it. I'm trying to show the easiest method I found so far. Okay, but if this is not easier, no problem. Whatever you have, go for that. As long as it's correct. Okay, in the next step, I'm going to multiply. So 4x squared minus, what is 36 times 4? 144. And then we have a minus the next thing. Minus x squared plus 6x. I'm too lazy to write down the denominator, so let's simplify the numerator here. We have 72 number and 144 number. When you combine them, what number we have? Minus 72. Then we have, let's say, 4x squared minus x squared. So we have 3x squared. Oh, that means the only single thing we have is 6x. It doesn't have any pair. So we have 3x squared plus 6x minus 72 over x plus 6, x minus 6 equals 0. First, let me get you the denominator. Once you combine the numerator, we don't want the denominator anymore. It's useless. So multiply x plus 6, x minus 6, both sides. So denominator cancel out. And we have 3x squared plus 6x minus 72 equals 0. So when we combine the numerator, the first one doesn't have anything, we kept it. Second one, we distributed. Third one, we also distributed. So we got this big line. We combined like terms. 4x squared minus 1x squared gives us 3x squared. 6x doesn't have any friends, so we just write it down. We have 72 minus 144, that gives us negative 72. So at the top, we have 3x squared plus 6x minus 72 over the denominator equals 0. Now the denominator is useless, so we cancel, and we got the numerator equals 1. And now you may think, oh, our x squared has 3 in the front, so 3 decimal. Right? You think that way? But actually you're wrong.
Oh,
Second,
no, mine is the second.
you're wrong
No, yeah.
because observe all the numbers. 3 is divisible by 3. 6 is also divisible by 3. 72 is also divisible by 3. So we can actually divide all the numbers by 3. When we can divide all the numbers by the coefficient, then we don't have to use this method. Because once we divide everything by 3, there will be no more a in front of x squared. Our a will become invisible. So we get x squared plus 2x. And now figure out 3 goes to 72 how many times? 24. See, it becomes much easier.
You have to do anything else?
Yep, factoring. So our variable is always the middle one, okay? Whenever we factor, the variable we use is always the middle one. Now, two numbers. When you multiply, gets 24. When you combine, you get 2. What are the two numbers?
6 and 4.
6 and 4. Now you have to decide the sign.
Plus 6 minus.
6 has to be plus because our second term is plus. Bigger number always gets the sign in front of x. And since we want to have 2, that means you have to subtract the 4 from 6. So x plus 6, 0 gives us x is negative 6. X minus 4, 0 gives us x is 4. Right? We get 2 solutions. True. Now see what happens. We go to check, can we accept both solution? Or there are some number we cannot have in our solution.
X.
So you go to our LCD. X plus 6 and x minus 6. We don't want any of them to be 0. Not equal 0 means we don't want any of them to be 0. That means we don't want x plus 6 to be 0, and we don't want x minus 6 to be 0. We don't want that. So we don't want x to be what number? And so there are two numbers we definitely don't want our x to be. One is positive 6, one is negative 6. Do we have any of them in our solution?
Yes.
Which one? Say. We deny that x equals negative 6 in our solution. Why? Because 1x is negative 6. That makes the denominator 0. Negative 6 plus 6 is a 0 in the denominator. Undefined. That's why we should check our solution. The solution we got, that any of them make the denominator 0. So you have two ways of checking. Either you look at the LCD and figure this out, or you substitute all of them into the denominator and say either one of them makes the denominator. Any question? Maybe I'll put this as extra credit in that now. Okay. The other one will be x and x squared. That one will be the main question, and this will be an extra credit. Any question? No. So this is first type of weird looking equation that doesn't look like quadratic, but at the end we use quadratic methods to solve. We use factoring, and many of you use quadratic formula, and then we solve for x. There is a second type, which is a triangle. Well, you may think, how triangle gives us a quadrant? It's weird, right? Well, funny thing, yeah. This also will give us something related to quadrant, like x squared. We are going to get x squared from there, and you have to solve that. What type of triangle is it? Right triangle. Good, right triangle. So anytime you see a right triangle, what comes in your mind? Pythagorean formula. What's the Pythagorean formula? A squared plus B squared equals C squared. What C represents? Hypotenuse. We don't care about NB. There could be anything. But our C must be the hypotenuse. Which side is hypotenuse? The longest side. That means our C is 10. And let's say this is A and this is B. So we have 5 squared, 2x squared equals 10 squared. A squared plus B squared equals C squared. And observe, I actually use parentheses to replace all the x's, all the variables. 5 with the parentheses squared, this is the parentheses squared, this is the parentheses squared.
So where'd you get 2x? In that.
Ready? 3x. My bad. 3x. Okay. What is 5 squared?
25.
25. It is simple. What is 3x squared?
Squared.
See, it's 9x squared. We have to distribute our square to 3 and also to x. So you get 9x squared. You see, we got x squared. X squared is a quadratic. What is 10 squared? 100. That's why it falls under quadratic, because when you do x squared is less than squared, we get x squared. And now to solve for x. So basic algebra. We want this x to be alone. We don't want the 25, we don't want the 9, we don't want the square. Which one we get rid of first? 25. So we subtract 25 and we get 9x squared. What is 100 minus 25? 75. And now which one we get rid of? We divide by 9. Can we reduce this by some number?
Yes. 3.
3. You cannot divide 75 by 9, but you can divide both of them by 3. So we get 25 over 3.
And then I think it will be 5 or square root 3.
So finally, we take the square root. And since the other side is a fraction, so let's split our root twice. So we have x is 5 over square root of 3. We should be done. Should be. But guess what? Most of it is a multiple choice. And you're not going to see this in the multiple choice.
Now you have to rationalize it.
Great. We're not going to see this in the multiple choice. We have a problem. Denominator has a radical. And usually people don't like to have radical in the denominator. I don't care, but math people, they don't like to have a root on the denominator. So we go back to our rationalizing. We multiply by what? So that this root from the denominator is vanished.
So square root 3.
If we have the same thing twice, the square and the root will cancel out. So there will be no root.
So it will be 5 square root of 3 over 3.
So multiply top and bottom by square root of 3. So we get 5 square root of 3 over square root of 3 square, but they cancel out. That was our goal, to cancel that out. So answer is 5 square root of 3 over 3.
Yeah, but in the homework, they make you find the racing side. They just give you x for a and b.
Okay, then let's see. It's 3 times 5 square root of 3 over 3. 3 cancel out. So our side is only 5 square root of 3.
That's
10 point, 11 point something, right?
yeah. So you have to use the quadratic to get that correct. I think it was
11.3.
11.3.
See? Because we are x squared, so it goes under quadratic. But still it was easy, right? It wasn't too bad.
Is that going to be on the exam?
It will. In the final exam, there will be at least one triangle to solve. Either easy
Oh,
one
yeah, that one wasn't over. That, yeah.
or a harder one. It's not hard, it just takes time. It's a little time consuming,
So
but the same thing.
You just,
final answer is 5 square root 3 of 3.
For x. But in my method, they wanted to find the missing side. If we say we're going to replace x with 5 square root 3 over 3, so 3 cancel out, the answer is 5 square root. For the length.
Okay.
But in the exam, I'm not going to ask you for the length, I'm going to ask you for x. So you're fine with that. My method has some extra things for you to do. Okay, the next one, no problem. What is our C here?
2x plus 2x plus 1.
So either one side, let's say this is our A, and this is B, and definitely this is C. So we have 3 square plus x plus 2 square is 2x plus 1 square. So anytime you see a triangle, you start with a square plus b square equals c square. Does this remind you of something we did before in exam 1? In exam 1, did you have to square something like that when you have plus or minus between them? Do you remember solving radical equation? A radical is one side, and the other side you have.
You have to make them equal to 0, right?
So either you can bring the left to the right to the left, it doesn't matter. Let me bring my right, no problem. So we have 9 plus. What do you do here? Are we allowed to distribute the power this way?
No.
There is no power rule for addition and subtraction. You can distribute the power when you're multiplying or dividing. So what do you do here? Good, you remember that. It's actually foiling. Same thing the other one. We must do FOIL. I mean, you don't have to if you can remember your special formula. But if you don't remember, FOILing is a hope. So you definitely cannot do distribution. And when you do FOIL, you get x squared plus 4x plus 4. You can check. Same thing on the other side, you're going to get 4x squared plus 4x plus 1. Do the FOILing, and you'll see this is the answer. See, I use the special formula. The special formula says, take the first one square, take the last one square, and then sign with 2 times their products. So 2 times x, that gives us 4x with the plus in the middle. Same thing here. Take the first one square, so 4x squared. Take the last one square, which is 1, and then 2 times their product. So 2 times 2x is 4x, 4x times 1 is 4x. Special formula. And now anytime we see solve means we want to see 0. So let's see 0, right? So which side is better to bring? The left to the right or right to the left? You can do right to the left, but look, we have bigger x squared here. Right? We have 4 of them. And here even 1 of them. We definitely want to have the bigger one on this position. So it's better to bring the left to the right. But before that, we can actually combine these two. Right? 4 and 9. So we have x squared plus 4x plus 13 on the left side. And now We subtract x squared, we subtract 4x, subtract 4x, we subtract 13, we subtract 13. You can bring right to the left, no problem. You left with negative x squared. And then you can multiply both sides by negative, turns it a positive. But I don't want to do two steps. I'm too lazy.
If you put right to the left, would that make like
It will make it negative.
no whatever
Then-
you complicate it later on?
Not complicated. You'll have negative x squared term, but you don't want negative x squared term.
Oh.
Because we always work with positive x squared. So you have to multiply both sides by negative. So you have to do one more line.
Oh.
Why wasting your time? So anytime something big, always bigger has more power, right? The older brother or the sister, they have priority over us. Did you guys notice that if you are not older one? Or even if you are older one, you always boss around the younger one. Do you notice that? It's true in our work life. Like whoever has a higher position, they boss you around. So always the bigger one has more power. So 4x squared definitely has more power. It's 4 times the smaller one. So we keep the bigger one and move everything for the smaller one. So now we have 0 in one side. And what do we have on the other side? 3x squared minus 2. Ah, no more x term. That means we don't have to factor like the other way we did. We can solve for x. We can divide by 3. Do it individually. Divide by 3. We get x squared minus 4 equals 0.
4.
So we add 4. We have x squared is 4.
And that's equal to plus minus.
This. It should be plus minus 2, right? Okay, so we have x equals either 2 or negative 2. But let's see what happens to our length of the triangle if x is a negative number. So we should check, like, does it give us something invalid or it doesn't?
Negative number, because you can't have negative distance.
Negative distance or 0 distance.
So we automatically cancel the negative one. And the answer is
It's not always true
that's for the whole.
because if the length doesn't give you negative, then you accept that. So you have to check, like, what happens to the length for the negative one.
For the one where we have to find the area of the square, you should find that formula. I think for that one you can use that negative. I'm not sure. No, it's 0.4.
Usually we don't accept the negative one, but it's actually based on what length you get. For example,
You have 4 plus negative.
we have x plus 2 is one side, right? One side, the b is x plus 2. Now, if you substitute x with negative 2, we get b equals 0. It means there is no length we have in the b. But it definitely says there's something we have for b, definitely bigger than 0, right? So b is definitely bigger than 0. So x equals negative 2 doesn't make sense. So that's why we disregard negative 2. But it's not always true. Sometimes when you substitute the negative number, you get a length that makes sense. That time we accept negative outside. Usually it doesn't make sense, but sometimes it does. So for this class, I believe it always doesn't make sense. So if you see a negative answer, always disregard for real life scenario. But in real life, actually it doesn't make sense. Okay. So our answer is x equals 2. And if they ask for the length, like my MATLAB, then we have a is 3, b is 2 plus 2, which is 4. And our c is 2x plus 1, which is 2 times 2 plus 1, that is 5. Oh, it's a 3, 4, 5 triangle. So this is for my method, the length. For Algebra, we don't have to do that. Because when x is -2, the length b becomes 0. 0 means it's a point. It doesn't have any length. Look at our b. We do definitely have a length, right? There are some number we have for our length b. But it says, hey, when x is -2, b doesn't exist. There is no b. But I do have a b. And that b is 4 units, 4 inches. They are telling you our b is 0 inches. By substituting x in all sides. This 2 is the only answer we accept. -2, we don't accept. Next question. So our A is 3, B is x plus 2. So we have 2 plus 2, which is 4 inches. Then C says 3x plus 1. So it's 2 times 2 plus 1, that gives us 5 inches. So my method wants you to have the length.
Are we gonna see any word problems in the exam that you're gonna give us? Please, like for the area of the triangle.
Which one you prefer not to have? Inequality or what problem?
Either.
Word problem.
Then we are going to do inequality and we are going to skip what problem for the next exam.
Which one is that?
Inequality, solve for x from the inequality.
That's fine. Yeah. we're gonna go through them.
No, that's how it works. Okay, so first table for non-quadratic was fraction. Second table non-quadratic was triangle. And now comes very weird looking something that is actually a quadratic. It definitely doesn't look like quadratic, right? Well, no problem. We are going to bring everything to one side as usual. So 2/5 minus 4x to the 1/5 plus 3 equals 0. The question is, how do we know we can use quadratic here? Well, there's only one condition. If you fulfill this condition, that means, yep, we can. The condition says, if the bigger power, like this, weird. If the bigger power is 2 times the smaller power, then we can use quadratic methods. Only one simple condition. If the bigger power is 2 times the smaller power, all life is bigger. Which one is bigger? 2/5 or 1/5? 2/5. So it's 2/5 is 2 times 1/5. No. 2/5 and 2 times 1/5 are the same? Definitely they are same. So the bigger power, 2 times the smaller power, that means you can solve it in quadratic methods. And quadratic method means factorable or quadratic formula. Let's see if it's factorable. Can you think of two numbers multiplied to 3 combined to -4?
-3 and -4.
-3 and -1. See, it is factorable. That means we -3 and -1. That means we can factor it using quadratic factoring method. And now comes something weird. All these times when we factor, we had x squared and then x, right? And when we factored, we use x as our variable. Now we don't have x squared. We don't have x. We have x in some weird powers. So which one makes sense to use as our variable? This thingy or this one?
The one thing.
The one with the smaller power. Because if you observe all the previous factoring, we had x squared as our first term, but when you factor, we actually use the smaller one. Why? Because if you FOIL them out, you get x times x squared, the bigger one. So we follow the same method. We always use the smaller power in factoring. Why? Because if you try to FOIL this out, you get x times x to the 1/5 times x to the 1/5, that turns into x to the 2/5. So if you multiply this, you definitely want to get this thing.
Wait, x to the 1/5 times x to the 1/5 would be, oh, because you add the exponent.
And now we know how to solve this, right? Anytime product of two things equals 0, what do we do next? We set each of them to be 0. X to the 1/5 minus 1 to be 0. That tells us x to the 1/5 is 3 and x to the 1/5 is 1. And now we have another problem. This is solve for x, not x to the 1. Great. 1/5 will get vanished if you multiply by 5. So if you have 1/5, you multiply by 5, they cancel out. We use this concept. We multiply both sides for both equations by 5. They cancel out, they cancel out. We are so smart, we get our x alone. What is 3 to the 5? There's 3, 3, 3, 3, 3, 3, 3, 3. What did you say? Oh, it's 243. It's a big number. And what is 1 to the any power? 1. See the exponent rule? I mean, you're done. You don't have to take anything. You're happy. Do you want to try one question by yourself before you go? No. Julia? Yeah. No, because we are not working with denominators. We are working with powers. Right. Same thing, the radical. If you work with radical, we have to check. So radical and denominator, we must check. Others, we don't. Okay. Okay, so this is our third part. Then we have 2 more types. We are doing function. And then we have done it 11.3.
There's a quiz today, right?
No,
There wasn't?
I didn't give any quiz. I'm planning not to give any quiz until the second exam. So have a good weekend, everyone.
Thank you very much.